Hello, grade 8 students. Today I will be discussing systems of linear equation. So what is systems of linear equation? It consists of two or more linear equation that is formed together. But then definitely for this topic, we will just be dealing with two linear equations in two variables. So the standard form is a sub 1 x plus b sub 1 y is equal to c sub 1 and a sub 2x plus b sub 2y is equal to c sub 2. And the solution to the system of linear equations in two variable consists of an ordered pair that satisfies both of the equations. So again, when we say ordered pair, yeah, it consists of the values of x and y or our x coordinate and y coordinate. Okay? So we have three types of systems of linear equation, and we better first understand these three types of linear equations before we can solve or before we find its solution, because it will definitely help us whether we are going to get one or two or more solutions for our systems. Okay, so let's start with the first type of systems for linear equation, which is what we call the consistent independent system. So let us first define it. So number one, it has one solution. The graphs are intersecting lines. So as you can see here, the graphs are intersecting, and the point of intersection of these two graphs is definitely the solution. So every graphs or every lines or intersecting line has a point of intersection. So just one. So they just intersect in one point. So definitely that will be the solution. And this type of system has different slopes and y-intercepts. And we can use this form to identify whether the type of system is consistent independent by just looking the numerical coefficients, which is a sub 1 over a sub 2. If it is not equal to b sub 1 over b sub 2, then that is the first type of system, which is consistent independent system. So let's take a look at this example here. So we have the equations x plus 2y equals negative 4 and 2x minus y is equal to 7. If I am going to graph these equations, so I was able to use the Desmos or the online graphing calculator. So if we are going to graph this system, the graphs looks like this. So as you can see, the graphs are intersecting. Actually, this point of intersection is the solution to the system. Okay, and later I will be using this form to check whether it is this is a consistent independent system. Next, let's take a look at the second type of system here, which is inconsistent system. For inconsistent system, it has no solution. Next, the graphs are parallel. So we all know that when we say parallel lines or parallel graphs, the lines do not intersect. So if the lines do not intersect, definitely there's no point of intersection. That's why it has no solution. And the slopes are the same, but then they have different y-intercepts. And then we're going to use the form a sub 1 over a sub 2 is equal to b sub 1 over b sub 2, which is not equal to c sub 1 over c sub 2. So, example of this type of system is 3x plus 2y equals 6 and 3x plus 2y is equal to negative 12. If I'm going to graph it, the graphs will be parallel. So, it has no solution. So, therefore, it is an inconsistent system. Let us go now to the third type of system, which is consistent dependent system. It has infinitely many solutions. The graphs are coinciding. Or other term for coinciding is overlapping. So if the graphs overlap, definitely there will be a lot of point of intersection. That's why the solutions are infinitely many. Definitely you cannot count the solutions because they overlap or they coincide. So here we have the same slopes and y-intercepts, and all the numerical coefficients, if we're going to get the quotient of it, they are all equal. So one example would be the system x minus 3y equals 3, and 2x minus 6y is equal to 6. If I'm going to graph it, it will look like this. So as you can see, you will just notice one line because they overlap. That's why you cannot see the other line. Okay? Because they coincide. Okay, now, okay, aside from graphing, definitely it will be harder for you to graph without definitely the use of graphing calculator. So another way is to use the form that we had a while ago. So for example, let us identify the type of system of 2x plus y equals 5 and x plus y is equal to 2. So here I will be just getting the quotients of the numerical coefficients. Okay, so getting first a sub 1, which is 2, over a sub 2, which is 1. So, yan. And then, next one, b sub 1, and then b sub 2, which is 1 over 1. And then, you just need to simplify. 2 divided by 1, the answer is 2. And 1 divided by 1, the answer is 1. So, definitely, they are not equal. So, if the first numerical coefficient will not be equal. Therefore, the type of system is consistent independent system. So again, the graphs are intersecting. It has one solution. Okay? Next, let us identify the type of system of this equation. So rewrite again the numerical coefficient. So 1 over 2. There. And then here, please include the sign. So here, your b sub 2, it's negative 3. And b sub 1, is negative 3. And then b sub 2 is negative 6. So that will be now negative 3 over negative 6. Okay? So 1/2, we cannot anymore simplify this. But negative 3 over negative 6 in simplified form is also 1/2. So therefore, they are equal. And then, we have to get the other column for c. So that is c sub 1, which is 3, over c sub 2, which is 6. So that will be 3 over 6. And we also know that if we're going to simplify 3 over 6, that is also 1/2. So therefore, they are all equal. For this type of system, it is called consistent dependent system, where the graphs are coinciding and it has infinitely many solutions. Okay, next example. Okay, so here, okay, I'm going to write the numerical coefficients. So that will be 1 over 1. And then next one, 1 over 1. So definitely they are equal. And then last one will be 5 over 3. So they are not equal to 1. So therefore, this type of system is inconsistent system. Another example, what if we have an equation which is not written in standard form? So what are we going to do first is to rewrite our equations in standard form. So again, the standard form of linear equation in two variables is ax plus by is equal to c. So if I'm going to change the first equation into the standard form, just simply transpose 6x on the other side of the equation. So we will have now negative 6x plus 3y is equal to negative 4. No need to multiply both sides of the equation by negative 1 because we are just checking the type of system here. Okay? Next, for the second equation, I will just be transposing y on the other side. So it will become now 2x minus y equals 5. After we rewrite both of the equations into the standard form, the next step is to get its numerical coefficients. Just simply divide. So we have negative 6 over 2, which is negative, as we get the quotient, the answer is negative 3. The next one, we have positive 3 over negative 1, which is also equal to negative 3. So they're equal negative 3. So we have to check whether the last one will be equal or not. Okay, so the last one will be negative 4 over negative 5, which is not equal to negative 3. So therefore, this type of system is what we call inconsistent system. Let's proceed to my last example. So here, okay, students hate fractions, but we need to give you examples with fractions. And the first equation is 1/2 x plus 1/2 y is equal to 1. You can work with fractions if you want. But if we had difficulty in dividing 1/2 by negative 2, better to change first this equation into simplified one where we don't have fractions. So to change that one, what I'm going to do here is to multiply both sides of the equation by 2. So as I multiply both sides of the equation by 2, 2 times 1 half, the answer is 1. So just simply x. And then 2 times 1 half, the answer is 1. So just y. And then 2 times 1, the answer is 2. And then just simply rewrite your second equation into the standard form by transposing 2x on the other side. So that will be negative 2x minus 2y is equal to negative 4. And then write the coefficients here. So we have now 1 over negative 2, which is negative 1 half. And then the next one is 1 also 1 over negative 2. So they are equal. And then last one, 2 over negative 4, which is also equal to negative 1 half. So they're all equal. So therefore, the type of system is consistent dependent system. That's it. Again, the three types of system will be consistent independent system. It has one solution. They have intersecting graphs. And the slopes and the y-intercepts are different. Okay? The next type of system is inconsistent system. It has no solution. The graphs are parallel. It has the same slope but different y-intercepts. And the last type is consistent dependent system. It has infinitely many solutions. We have coinciding graphs. And then it has the same slopes and same y-intercepts. I hope you were able to learn. Thank you so much, grade 8. See you again next time. Thank you.